Chimere is a distant planet. It is defined by waves of life brought from Earth and set free to evolve independently in this new context. The indigenous life of the planet, swarms of microbes called magic by the people who live there, are what harvest Earth organisms and make copies on Chimere. As the asteroid which concluded the Mesozoic never struck Chimere, dinosaurs remain the dominant terrestrial megafauna. The marine habitats of the known world and beyond are a formidable battleground of sea monsters both strange and familiar. Great white sharks, common dolphins, orcas, and swordfish compete with mosasaurs, plesiosaurs, and the mighty megalodon. Even though some members of the cast are unfamiliar to us, in broad strokes it is a fairly familiar ecosystem. Most corals are of the same species we have throughout our tropics today. The kelp is of the same species that is found off the coast of Alaska and California, and many of the fish are found in our modern seaways. Pods of whales, which may not all be of familiar species, but of familiar clades, feed on shoals of krill and baitfish. It did not take long for assembly surveys of the northern hemisphere to demonstrate that this was very much not the case up north. Chimere is a massive planet. With approximately 3 times the mass of Earth and nearly 1.7 times its radius, there is a tremendous amount of territory to cover. It is also a hothouse climate compared to our own. While the known world roughly corresponds with our tropics to temperate climate in terms of temperatures, the southern range doesn't get quite as cold as our polar regions. The equator, conversely, is astonishingly hot. It acts as a substantial barrier, and this is reflected in the high degree of endemic fauna both on land and in sea. Treatises of the Great Library long recorded how many distinct species and faunal groups reside north of the equator, but it's a phenomenon the Assembly only recently began to verify. This may seem strange at first, but it's actually how things used to be on Earth, albeit at less of an extreme. It is best represented by what appears to be a relatively restricted range of many cetacean and pinniped groups until the Pliocene and Pleistocene, when oceans got cold enough to enable large-scale passage. Humpback whales and relatives of elephant seals, for example, have had a long fossil record in the southern hemisphere and seem to have only come north once things cooled down enough in the past million years or so. Eared seals seem to have largely, if not entirely, been endemic to the northern Pacific until the Pleistocene, and now their greatest diversity is in the southern hemisphere. Right whales appear to have been restricted to the northern Atlantic at least until the Pliocene enabled a spread around South America to establish the Pacific population. Cooling oceans during the ice ages pushed everyone to the center and made the tropics tolerable to what had once been temperate fauna. Animals, cosmopolitans in our oceans today, are an exception, not the norm, and many oceans continue to warm. It is assumed that these population divides will continue. Already, many cetaceans have genetically isolated populations divided by the tropics throughout recorded history, and this will only increase as higher ocean temperatures increase. Ocean temperatures is, of course, not the only factor in population division, with food supply, currents, and migration also at play, but the temperature divide is worth noting. It must be emphasized that this is a trend, not a law or physical or impenetrable barrier. There are many instances of individuals crossing the equatorial waters with no issue. Smaller cetaceans and pinnipeds have a much easier time with the passage, and tropical specialists, like the spotted and common dolphin, of course freely cross the equator even in the hottest times of the year. but it is a general trend of difficult passage that many marine fauna were only able to pass back and forth in large numbers, sufficient enough to establish new populations during the context of the Pliocene and Pleistocene. The conditions that threw our oceans together have not occurred in Chimere in a very long time, so it was quite jarring for Earth naturalists to first discover just how endemic many clades and even biomes are in the hemispheric divide. There is a reputation that the northern hemisphere is a primordial place due to how few modern clades can be found up there, but of course these habitats have no shortage of competition and continue to evolve in their own ecological arms races. A survey at the foundation of the food chain, one can discern a greater quantity of indigenous magic amidst the plankton base. Many species of baitfish haven't had Earth relatives since the Mesozoic. There is interchange between north and south, but the heat of equatorial waters, coupled with equatorial currents, and the fact that a substantial portion of the equator is continental, means that there's not nearly as much passage as one might assume using modern Earth as a precedent, where most of our continents span north to south and facilitate a lot more marine interchange, at least along those lines. Some of the famous fish in the northern hemisphere include encodine fish. In the southern hemisphere, these fish once reached 6 meters in the largest species, though today these giants are extinct. The truleco, or Teratognathus, is found throughout the tropics and temperate waters of the northern hemisphere, and a meter-long population is found in the inland sea, mostly concentrated near the Kentarime Islands. They tend to be on the smaller side in the known world, generally a trend in their warmer range, though a 5-meter truleco was captured in the waters near the Permian Islands, and generally they get quite large in their northern range. Another giant ray-finned fish is the batsugai. The largest species, the batsugai itself, can exceed 6 meters in the largest males and weigh well over a ton. This pelagic fish is rarely found in the known world, usually only as juveniles, though they sometimes are drawn into current channels as adults. A smaller species is found in the southern hemisphere, but the batsugai is primarily endemic to the northern oceans. This southern species directly competes with a number of species of tuna. Schools of batsugai tend to comprise of fish and around the same age and size class. Schools of hundreds of animals are often found together, especially in regions of abundant food. Despite their great size, they are mesopredators that hunt prey small enough to swallow. The northern oceans, especially those above Kai Rule, have reported not only the largest batsugai, but also schools containing tens of thousands of individuals. They are very common, very large fish, and are an important food source for many enormous predators. Cephalopods are also in great abundance. Krakens are an unnatural grouping, a generic term for any large ammonite, octopus, or squid, and kraken of all three groups are present in the northern hemisphere. By far the most abundant is the bearded crake. With a mantle around 2 meters long, they are roughly the same size as the average giant squid of Earth, although they are much shorter, owing to far shorter arms and tentacles. They are generally regarded as close cousins of the Humboldt squid, though this has not been verified by any genetic studies. They are formidable predators, forming large shoals of thousands that feed in shallows at night and in the depths during the day. Largest of any Chimeran kraken is the ghost kraken. This species is not endemic to the northern hemisphere as they were originally described in the Great Caline Sea, though their greatest population and presumed origin is up north. Using arms where the suction cups have adapted into branching filters, they filter feed a wide range of habitats in search of suitable prey. They belong to a clade of much smaller benthic feeders that use similar feeding apparati to comb through sediment, though ghost kraken tend to feed in more open waters. Though long assumed to be cuttlefish due to their general shape, they instead appear to belong to a related squid clade of a similar body plan, and lacking a cuttlebone enables them to explore much deeper waters in search of prey. Things are generally more familiar in the tropics, such as several dolphin species like the common and spotted dolphin, and a few squid specialists and cetotheres from the known world are in abundance. Worthy of note is that they are all small compared to the more famous cetaceans we think of today. Large whales like humpback and sun whales only cross the boundary as occasional specimens, and none have established northern populations. Many pods of female sperm whale and their calves have been found north of the equator. The heat of these waters is generally prohibitive for large males. Most bulls venture south upon maturity, though the fact that a few males have been spotted in the north means that they may not have as much of a southern restriction as was once assumed to have been the case. It's possible that it is simply a matter of their relatively recent introduction in the past million years or so. As more males are born in the tropics and spread north rather than south, as the majority goes, the species might achieve abundant global distribution. The Great Kaleen Sea and its canyon channels offer tremendous feeding opportunities that most males prefer to hunt in, but there's enough promise in the north, especially in regions with abundant bearded crake, that it's reasonable to assume that they will establish themselves up north as well. The largest known endemic cetacean of the northern hemisphere is the fencing whale. Despite its name, the long rostrum of these toothed whales is not used for combat. It is instead primarily used in conjunction with echolocation to sift through sediment and pick up an abundance of benthic fauna. Their teeth are long and thin, ending in capped tips which help them filter feed. While there are a few baleen whales, they are all quite small, perhaps due to several well-established lineages of large filter feeders already dominating these niches in the north. There are a wide range of sharks in the northern hemisphere, making up the greatest abundance of predatory niches. Some, such as hammerhead and mako sharks, are quite familiar to us. Megalodon is a shark which prefers subtropical and temperate latitudes, though they can tolerate tropics and subpolar waters. Their coldest ranges include almost exclusively the large females, who in the southern hemisphere follow whale herds in the warm waters to give birth. Megalodon is more abundant in the southern hemisphere, though they are not rare to the north. Other sharks are far less familiar. The frogmouth sharks of the known world belong to a shark lineage which came to Chimere since the first Jurassic dynasty. They are so named for their very wide jaws. There are several species in the known world, with the largest being the greater frogmouth, and females of which can reach 15 feet in length and match approaching a ton. There is a fraction of the size this clade can achieve in the northern hemisphere. The Flenser shark, so named for their formidable cutting capacity the shark can achieve with lateral shakes, can reach 10 meters in their largest females. They are not a fast shark, stalking prey slowly before an ambush, but they are capable of bringing down prey much larger than themselves. Perhaps because they are able to get by on less prey than Megalodon, which has a regionally endemic metabolism and needs to eat more than twice as many calories for its size, Flenser sharks are far more abundant. The largest shark in Chimere, with their biggest females rivaling the largest Megalodon Methuselah, is the trawler shark. Males rarely exceed 12 meters, but the largest female reliably measured by the assembly was nearly 20 meters, and a specimen estimated to be 23 meters was reportedly spotted but dived before it could be measured. They indulge on a wide variety of microfauna throughout the year, feeding mostly on the surface and near coastal waters, but sometimes trawl in the mesopelagic zone during the day, but during the summer, they congregate in the northern coastal waters of the polar continent. Glaciers melt during the summer, and this creates a runoff of nutrients and algae, which concentrates tiny crustaceans and fish in their trillions. This smorgasbord supports a great diversity in biomass of very large filter feeders. Size not only affords an ability to consume massive quantities of these plankton feeder congregations, but they also make travel from winter feeding grounds more efficient. Trawler sharks may be a common sight at these feeding grounds, but by far the most abundant filter feeders belong to perhaps an unexpected clade: the Mosasaurs. As discussed in the Catabo episode a couple weeks ago, Mosasaurs have been in Chimere since the Cretaceous, and appear to have fairly quickly established themselves in a wide range of niches. Some are fish or squid specialists, a very lucrative niche. In the known world, the Oja is a tuniform mosasaur built very similar in a lot of ways to familiar dolphins. Though they lack echolocation, their senses of smell to find prey, and a combination of touch and vision to catch it once they locate it, are indeed quite successful in the inland sea. In the northern hemisphere, it is this clade, not dolphins, which dominate the niches we most associate with dolphins today. They were long assumed to be ichthyosaurs, and later ichthyosaur mimics common during the Tyrant dynasty, but genetic studies confirm what many anatomists instead suspected. They belong to a sister clade of the cetapancetids, which we will address shortly. The ado is a larger species in the same genus as the oja. They are a bit more generalist. While still feeding on a lot of fish, they also hunt marine tetrapods and large squid. They are primarily temperate and subtropical animals, and while they haven't been seen in the known world, historical accounts suggest that they may have occasionally ventured into the current channels following prey. For the most part, though, it appears the heat of the equatorial waters keeps them primarily endemic to the northern hemisphere. Ado are not as social as the oja, but they do live in pods of around a dozen related cows and their offspring. Young take between 8 and 10 years to reach maturity, a bit faster than cetapancetids, and while they hunt on their own, young of both sexes remain with their pods at least until sexual maturity before they depart. Females often remain with the pod, but if it gets too large, or food too scarce, factions may break off. Males are sometimes solitary, but it is not uncommon to find a few related males living and hunting together, typically cousins at around the same age rather than brothers, as most pregnancies are of single offspring, so they grow up with relatives instead. There are some mosasaurs that retain the basal body plan and lifestyle as generalist predators, but these are often restricted to the tropics. The Kalutu, for example, is a presumed tylosaurine, best known for its population near the Kenturim Islands, although they are found throughout the northern Trachayam Sea, into the Crescent, and along the tropical waters of Arvel and western Nikar. Their greatest abundance is in the northern hemisphere. Filter feeding is not a lifestyle we have evidence for in mosasaurs in our own prehistory, but like many filter feeders, it seems their evolution began as benthic feeders, sifting through sediment along the sea floor in search of small crustaceans, fish, and mollusks. While their filters were initially mistaken for baleen by initial researchers, they are indeed teeth with feather-like serrations to aid in sifting. Some of the more basal species retain their ancestral lifestyle along the seafloor, but the family Saurocetidae has between 1 and 200 teeth with intricate serrations that they use to filter small prey. Some are still bottom feeders, swimming along their sides as they sift through sediment, but the most abundant and diverse genus, Saurocetus itself, are generally feeders along the surface, or generally high in the water column. The Dicobile is the only member of this clade which sometimes ventures into the known world, and, as with many other species, follow prey through the current channels. Cetothere whales very much dominate this niche in the Trachayam Sea, so they are not a common sight, though they are mistaken for cetotheres with enough frequency on initial spotting that it is entirely possible that they are more abundant in the known world than generally assumed. With very long flippers, they are quite dynamic swimmers, generally encircling a group of prey to tighten them before going in for a swallow. Their skull flexibility, or cranial kinesis, is quite extreme, allowing for a very wide gape as they ram feed, and a pair of sacs in their chest connected to the mouth can draw in a lot of secondary water. Not as extreme as rorqual whales, but they are still able to take in quite a lot of water and potential prey. The largest known saurocoetid is the scylla. They are by several meters the longest Mosasaur in Chimere. While these filter feeders aren't deadly to anything much larger than a few inches, they were originally assumed to be formidable predators, hence the name in reference to the deadly sea monster in Greek mythology. The name stuck, and while they may be filter feeders, they are far from gentle giants, with males often employing their barnacled rostrum to inflict fearsome, if usually only superficial wounds, to each other and potential predators. Female scylla often live in large yet loose herds of a few dozen animals, while males often tend to remain solitary or form small coalitions of usually related males. Despite their great size, with males often approaching 20 meters, they are not without dangers. In the summer, many species of saurocoetid assemble with other filter feeders at the Congregation of Plankton Specialists. There are so many swarms of krill and similar microfauna along these coasts that some giants like the scylla, trawler sharks, and ghost kraken can get a majority of the calories they need throughout the year in just a few months. Because these concentrations are in such tremendous density as well as sheer abundance, millions of these multi-ton filter feeders will assemble for their due. Being large makes migrations more efficient, so many of these animals are absolutely enormous, and their great size also affords protection for what is to come. Such a congregation of enormous fauna does not go unnoticed by predators. The Mosasaur is a large mosasaur and widely regarded as the apex predator of the warm oceans of Chimere. Megalodon may be larger, but the largest specimens of these sharks are not common, and they rarely can tolerate the warmer waters preferred by the Mosasaur, so these catapanceted mosasaurs often have minimal competition. Their diet is generalist, and they usually prefer prey that they can swallow whole, though will hunt any number of cetacean, marine reptile, and fish approaching their own tremendous size. It is typical for individuals to specialize in a particular sort of game rather than all Mosasaur eating anything in their environment. Cows live in territorial groups of related females and rarely exceed 13 meters and 12 tons, while the largest bulls can approach 16 meters and a staggering 30 tons. They are lighter than whales of similar dimensions, considering their lack of a blubber analog, but their bodies are still quite robust. With a fast metabolism, their bodies are very demanding, and they require 300 to 1,000 kilos of food every day, depending on size and activity. This makes their success and abundance a clear reflection of Chimere's marine productivity, as without a lot of food, they would quickly go extinct. Especially while swimming, it is easy to see how catapanceted mosasaurs are closely related to the ichthyosaur mimics, which also possess a tuniform body plan and locomotion. A rigid torso and powerful tail is extremely efficient, and they are shockingly fast for their size. Large flippers and a more flexible neck compromise their speed, but does help make them surprisingly agile in turning to grab prey they might miss on a charge. All this makes for a highly efficient and successful apex predator. Large male Mosasaur have occasionally been spotted in the northern filter feeder gatherings, though even in the summer, the water is usually far too cold for all but the most determined individuals to endure for the sake of abundant prey. However, there is a related species much more specialized to these cold conditions. The trochlonaut is another species of Catapancetus insulated by a layer of fat blubber analog. Conversely, this means they cannot endure the heat of equatorial waters, so is endemic to the northern hemisphere. They live much like the Mosasaur, with groups of females living in loose pods of cousins and their offspring, and sometimes hunting in groups, though usually the social living is for defense of their young. They eat a wide range of prey. Compared to the Mosasaur, they generally prefer larger game, though, like their tropical cousins, individuals often develop a preference and specialization, getting quite proficient at taking down certain game. That said, when the crowds of filter feeders gather, these marauders will take down whatever they can get. That's not to say their prey is defenseless, and there have been plenty of accounts of skyla and trawler sharks defending and even killing troclonot who attack them, though these groups of intelligent mosasaurs are usually capable of making ample kills. Megalodon in these waters do pose a threat, but groups of troclonot are usually able to defend themselves. A threat they may not be up for is the largest and most dangerous predator in all of Chimere, the kumka. These enormous plesiosaurs may resemble pliosaurs of the Jurassic and Cretaceous, but they actually belong to the long-necked plesiosaur lineages, which independently grew a massive head and short neck to support it. They are much slower than many of the cephalopods, marine reptiles, and fish that they hunt, which raises many questions about how such a large endothermic predator could survive. Their swimming stroke is very slow, which not only seems to enable them to sneak up on sleeping or unsuspecting prey. Cephalopods make up a large portion of their year-round diet, and moving slow and undetected appears to enable a highly successful strategy. They can hold their breath for over 3 hours, critical when both setting up ambushing or searching for prey undetected. Their sense of smell is suspected to be very sensitive, as has been demonstrated in several other plesiosaurs in the known world, like the unrelated but somewhat analogous Xanatel, though the exact limits of their sense of smell are unknown. Their eyes are massive, with large bulls perhaps having the largest eyes in all of Chimere, but in deep water, it is likely the ample sensory pits along their snout are what they use to actually detect and catch prey. At the smorgasbord of the polar continent's coastal waters, the kumka enjoys its choice of prey. Megalodon and mosasaurs may be fast enough to easily outpace them, but actually fighting these leviathans is a daunting prospect. They may be slow, but they are surprisingly nimble, and the tusks of the largest bulls protrude 1.5 meters from their root. Most other predators simply clear out of the way. Stolen kills make up a majority of their diet, especially in the largest males. Sometimes fights to defend these kills do occur, usually toward the end of the season when prey disperses and a good kill is worth fighting for, but it is a rare kumka who actually is killed in these confrontations. There are accounts of both Megalodon and Troclonot bringing down these formidable monsters, but for the most part, the cryptic king takes his claim and easily dispatches any who would dare challenge him. The many layers of blubber analog which keep these slow, cryptic predators warm prevents them from tolerating even warmer temperate waters, so only a few individuals who pass south toward the known world would be disoriented and likely unhealthy animals. According to treatises of the Great Library, it has happened on occasion, but the Assembly has no evidence to corroborate. The great serpent Jormungandr is another enormous predator endemic to the northern hemisphere. The phylogeny of these snakes is debated, and they may not even be true snakes under technical definition, but as huge legless lizards at least belonging to a sister clade to the Madsoids. The largest specimen verified by the Assembly was over 22 meters long, but much larger examples have been attested to. One of the longest animals in Chimere, though given their very gracile build, notably lighter than other contenders for size. Given this build, they are very efficient in the marine horsetail forests, quietly navigating with undulating strokes, though they are quite vulnerable in open water. Their bodies are specialized to stabilize, so cannot constrict, meaning their bite is their only weapon. A fearsome weapon, but against much faster or more powerful opponents, they can easily be killed. Indeed, the largest measured specimen had been killed by a group of female trochlonaut mosasaurs. In their element, though, they are the top predator. This plant, the marine horsetail, is often compared in analogue to kelp. Forests grow along temperate to polar coastal waters between 10 and 50 meters deep. They are difficult to navigate, and most large animals avoid them, meaning Jormungandr patrol this domain absent contest. Two lineages of non-mammal therapsids have been taken to the sea in the Permian Islands and continent respectively. First, and discussed in episodes past, are two independent radiations of Dicynodont. One, which feed primarily on seagrass in the warmer waters, include the mogao of the known world. They are found throughout the tropics and subtropics of both hemispheres. Though some on their homeland are semi-aquatic, it is the fully aquatic clade which has representatives throughout Chimere. The second clade of Dicynodonts were initially assumed to be a strange walrus. They are found from temperate latitudes all the way to the northern polar continent. They are mostly herbivores, feeding primarily on horsetail forests that grow in the shallow coasts, though a few are omnivores that use their powerful tongues to break apart a range of mollusks and crustaceans. The resplendent walrus is a very common species found throughout most of the northern hemisphere. The marine olifant is the largest Dicynodont, and are too large to haul ashore. These creatures remain in the relative safety of the horsetail forests, though at their great size and armed with tusks that can easily exceed 3 meters in length, they can defend themselves in open water. Like the resplendent walrus, they are found wherever their food grows, though they are far more abundant in the colder northern waters. Therocephalians, namely the clade Eborpheltheria, also produced two lineages that took to the sea. First to enter the water, which they did back during the Tyrant Dynasty, were the thalassopiths. The Wakatelu, a species specialized in ammonites, is the only animal of this clade in the known world, although they have a wide diversity in the northern hemisphere, with a few generalists, but some that specialize in crustaceans, in various cephalopods, and even a few that specialize in a certain species of very abundant prey. The high vault of their palate, coupled with a strong tongue, enables powerful suction that they can easily and efficiently evict their desirable portions of shelled prey. The second clade of aquatic therocephalians come from the draconiforms. This lineage is most famous for the winged dragons discussed last month. There are, however, many lineages within this clade, most of which did not evolve wings. They are a largely arboreal clade, when compared to small cats and monkeys in assembly discussions. However, one group became larger predators, and from this group evolved a terrestrial branch that quickly took to the rivers. During the Tyrant Dynasty, they resembled otters. As niches opened up following the dynastic extinction, in the upheaval, these river creatures got massive, and while some challenged the crocodiles for terrestrial predator niches in the dense southern jungles, others took to the sea. These are the marine dragons. The only of these animals to have a population within the known world is the capricorn, or common reef dragon. They are quite recent migrants, and are very much in the shadow of the catabo. They are generalist predators patrolling the reef, in search of any number of fish, crustacean, or mollusk prey. They are intelligent, persistent, and inquisitive predators. Capricorn have no cold water tolerance, so rarely travel south of the Kenterim Islands. As females must climb ashore to lay eggs and guard them for over a month, they are restricted in size. Males in particular have vibrant, colorful displays, which become particularly colorful during the mating season, but thankfully these colors fade after only a few meters of water, so don't inhibit their hunting. They are very good climbers, so females can usually nest on places inaccessible to most potential nest raiders. Their venom spray isn't much use underwater. For males, it is brightly colored and an important component of their mating display, and both sexes will spray to ward off threats while resting on land. The venom can cause temporary blindness in mammals in particular, so they are often left alone once they comfortably establish themselves. It is for this reason that they are also called basilisks. While Capricorn are tropical dragons, most of their cousins are temperate animals. A few polar examples do exist, like the Jotunhundir. These are mostly fish and squid hunters, while lounging on the beaches of the northern polar continent in their thousands. They are a large and abundant species, but many of the smaller species, as much as a dozen polar sea dragons, have been identified. Early on, they were mistaken for seals or sea lions, and in niche and social structure, they are quite analogous. It is rumored that at least one smaller species of polar sea dragon hatches their egg within their body, meaning that they don't need to incubate on land. If this is true and this lineage persists, they could become a dominant presence in the seas, perhaps as dominant as Mosasaurs, once they fully shrug off ties to land. Largest of these therocephalians is the Tiamat. Exceptional specimens can reach 16 meters, making them among the largest marine predators. Females must still haul out on shore to nest, so they are capped at roughly the same size as the largest prehistoric crocodiles, between 8 and 11 meters, but males are much larger and more aquatic. Females are generally more abundant in the temperate waters, but males will join the congregations of filter feeder hunts in the polar summers. Like other draconiforms, they spit venom. As with their cousins, the males incorporate this into a radiant, multicolored display which can be 10 meters high in healthy bulls. Females generally spray venom to defend themselves while nesting on land, a time when they are otherwise very vulnerable. While this episode has only scratched the surface of the endemic biodiversity of fauna in the northern hemisphere, I hope it has illustrated just how unconventional our modern oceans are, even compared to recent prehistory, due to the cold climate within the past few million years, making cosmopolitan distribution more common. Again, the hot equatorial waters are not a physical barrier, but it does mean that there's a lot more endemic marine castes to the north and south under different conditions than in our recent past. As climate temperatures have risen within the past 10,000 years ago, notably within the past century, many populations are now genetically isolated in ways that they didn't used to be. As the fauna of Chimere's oceans did not undergo this period of a cool climate leading to a once endemic northern and southern fauna being thrown together, there remains a general trend of exclusion, especially amongst large animals. Cheers and much thanks to Ian for sponsoring this episode. I've had several episodes exploring the northern hemisphere, but I focused on terrestrial fauna in those installments, so this was a very exciting opportunity to tie them all together in the marine habitats connecting these various realms. The equatorial barrier is also a concept I've hinted at in a few episodes, but never covered in much detail. It was such a compelling notion when an acquaintance first told me I should look into it. It's very easy and understandable to assume that a lot of the way our ecosystems exist today is the norm, but we live in pretty exceptional times, even excluding human impact on the environment. Even a change that seems simple at face value, that being Chimere has not had an exceptional cooling trend that we've seen on Earth, has had abundant impacts on this project, and an equatorial heat causing substantial endemism is not one that I anticipated, but has resulted in a lot of fun opportunities, in no small part because this context enables me to incorporate a ton of new endemic fauna. Thanks again to Ian for funding this opportunity, to my Patreon patrons for your support, and thank you so much for watching. Have a fantastic day, everyone. Cheers, folks!